Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we have to evaluate this limit, that is limit x tends to 0, 1 plus x raised to 1 over 4 minus 1 minus x raised to 1 over 5 divided by x, right? So here we have an algebraic expression whose limit is to be calculated when x tends to 0, right? So here we'll see a method how to evaluate these type of limits. So let us call this limit as L, right? Now see, in order to evaluate these type of limits, what we do, we make some algebraic manipulations, right? So let us write the numerator like this, that is 1 plus x raised to 1 over 4 minus 1, and then here we have 1 minus x raised to 1 over 5 plus 1, right? And in the denominator we have x. So what we have done in the numerator, we have added 1 and subtracted 1. So now let us rewrite this expression like this. That is, let us break this limit into two parts, right? Or in other words, let us break this expression into two parts like this: 1 plus x raised to 1 over 4 minus 1 divided by x, and then we can take here the negative sign and we have 1 minus x raised to 1 over 5 minus 1, because this negative and this negative makes it positive, right? And here we have x, right? So now let us take this expression as A and this expression as B, right? So that we have limit x tends to 0 and we have A minus B, right? So first we'll calculate this limit, that is limit x tends to 0, A, right? And A is 1 plus x raised to 1 over 4 minus 1 over x, right? So we can write it like this: 1 plus x raised to 1 over 4 minus 1 over x, right? Okay, now let us write this expression like this: 1 plus x raised to 1 over 4 minus 1. And now in this case, let us change the denominator, right? So x can be written as 1 plus x and minus 1, right? So here we have added 1 and subtracted 1, right? So now here we have arrived at an important conclusion, that is limit x tends to a, x raised to n minus a raised to n divided by x minus a is equal to n a n minus 1, right? So here we can substitute, say 1 plus x is equal to t, right? So now if we take 1 plus x is equal to t, then when x tends to 0, then t tends to 1 plus 0, that is 1, right? And replacing 1 plus x by t here, this limit reduces to limit t tends to 1, and here we have t raised to 1 over 4 minus 1 divided by t minus 1, right? So now we can rewrite this expression as t tends to 1, t raised to 1 over 4 minus 1 raised to 1 over 4, because we can write 1 as 1 raised to 1 over 4, and here we have t minus 1, right? So now if we compare this limit with this one, then obviously the variable x is t and a is 1 and the value of n is equal to 1 over 4, right? So the value of this limit as per this result is equal to n times a raised to n minus 1. So n is 1 over 4 n is 1 over 4, a is 1, and here we have 1 over 4 minus 1, right? So 1 raised to 1 over 4 minus 1 is simply 1. So we have simply 1 over 4 times 1, that is equal to 1 over 4, right? So this limit is equal to 1 over 4. So now let us calculate limit x tends to 0 b, right? So limit x tends to 0 b is given by limit x tends to 0, and b is 1 minus x raised to 1 over 5 minus 1 divided by x, right? So now let us rewrite this expression as 1 minus x raised to 1 over 5 minus 1, and here we can write this x as 1 minus x, then we have here minus 1, and since 1 and minus 1 get cancelled, so we are left with minus x. So in order to neutralize this negative sign, we can place a negative sign over here, right? So this expression can be written as negative limit x tends to 0, 1 minus x raised to 1 over 5 minus 1 divided by 1 minus x minus 1. So now let us take t is equal to 1 minus x, right? So when x tends to 0, then t tends to 1, right? So now this limit takes the form minus, here we have limit t tends to 1, and here 1 minus x is t, so we have t raised to 1 over 5 minus 1 divided by 1 minus x is t, so we have t minus 1, right? Now since this 1 can be written as 1 raised to 1 over 5, right? So to make it identical with this form, so if we compare this limit with this one, then value of a is 1, then the value of n is 1 over 5, right? So the value of this limit is minus n a n minus 1, right? So here n is 1 over 5 and a is 1, and we have 1 over 5 minus 1, right? So 1 raised to 1 over 5 minus 1 is 1, so we have minus 1 over 5 times 1, that is equal to minus 1 over 5, right? So viewers, we have calculated that limit x tends to 0 b is equal to minus 1 over 5, right? So now the value of this limit L is given by limit x tends to 0 a minus limit x tends to 0 b, and here we have 1 over 4, then here we have minus 1 over 5, right? So this is 1 over 4 plus 1 over 5, so we can add these two rational numbers. So here we have 20, then we have 5 plus 4, that is 9 over 20, right? So the value of this limit is equal to 9 over 20, right? And remember, to evaluate these type of limits, we always make use of this important result from limits, right? Where this n is a rational number.